Theorem 7. Tangents to a circle from the same point are equal in length. Tangent to a circle from the same point are equal in length. So here we have a tangent from this point here, and it's going to touch the circumference here, the point of tangency here. We have another tangent from the same point here, right, to the circumference. So what we're looking at is where it actually touched the circumference. We're not looking at this extra piece here. So what you can do is pay attention to this white line. Okay, it's from where the two tangents meet to where one of the tangents touches the circumference, the point of tangency, to the next point of tangency. Okay, just that we're looking at. Okay, so from the point of contact between the two tangents to the point of contact between the tangent and the circumference, those two tangents will be equal in length. So tangent to a circle from the same point are equal in length. And we use two dashes on the white line to symbolize the equality of these two tangents. And that's it for that theorem. Theorem 8. The line joining an external point to a circle bisects the angle between the tangents. Okay, well, that's a little bit confusing, so I'm going to just look into what it says here. The line joining an external point, so let's look at that. Okay, the line joining an external point to the center of a circle. The line joining an external point to the center of a circle. Okay, so we have the external point here, and we're going to have a line that passes from this point, from this external point. We're going to have a line that is drawn to the center. Okay, so this is point to the center of the circle. So we're going to have a line drawn from the center to the point of contact between the two tangents. And that line that we're going to draw will bisect the angle between the two tangents. This is the angle between the two tangents of 70. Bisect means cut into. So let's see how that turns out. And there we have the line that's drawn from the point of contact between both tangents. Cutted it into two equal parts. Cut the area, the angle between here in two equal parts, going to the center of the circle. So that 70 is divided in two parts now, in 35 and 35 degrees. Okay, so now we're going to combine theorem 4 and 8 to help us find the missing angles quickly. Okay, so that's theorem 8. There's going to be 35 here and 35 down here for sure to give us 70. Now, theorem 4 is where we have the radius meets a tangent. Can you remember what angle? The radius meet the tangent at what angle? At 90 degrees. So radius meet tangent at 90 degrees. So how would we find this angle right here? Can you be able to figure it out? Okay, so let's check it out. So what we know so far is that we have that four-sided shape now divided into two triangles. Isn't that so? So we have this triangle at the top with 90 degrees, x degrees, and 35 degrees. What we know is that these three angles should add up to 180 degrees. We have 90 already, so we need 90 more. So x plus 35 should also be equal to 90. So x is equal to 90 minus 35 degrees. And so we can say x is equal to, that's 55 degrees. Okay. Okay, so these two angles should be complementary. In other words, add up to 90 degrees. Okay. And if you wanted, we could have done it the other way around. We could have said 90 plus 35, that's 125. And so we could have said down here, we could have said 180 degrees minus 135, 125, I should say. Okay, so that should be 125 degrees. And that will actually give us 55 degrees. And the reason here is sum of angles in a triangle. That's the reason we're looking at. And so x is equal to 55 degrees. So x is 55 degrees. What angle is this here? Notice it's 35, this is 35, this is 90, this is 90. So x here must also be 55 degrees. And so what we've seen that this line not only divides this angle here into equal parts, but it also divides this angle here into equal parts, 55 and 55. So this angle here would actually be 110 degrees. So if you were asked to find this angle here, let's call it Z, what angle would this angle here be? Now remember, this is the center of the circle. What angle is this over here? For certainty, it looks more than it's a reflex angle actually, because this angle here will be 180. From here to here will be 180, a straight line. And so more than a straight line will be a reflex angle, more than 180. How do we get that? Well, we should recognize that this is actually a circle, right? The center of the circle, we have a circle here. And this part here is 110. 55 degrees and 55 degrees more, that's 110 degrees. And this angle here should add with the 110 to give you 360. So angle Z will be equal to 360 degrees minus the 110 degrees. And angle Z will be equal to 250 degrees. This angle here is 250 degrees. Okay, and that will be our answer there. Okay, and what's the reason for this? And you want to state your answer. You want to state the reason. I don't have enough space here, so you state the reason as angles at a point. Angles at a point sum to 360 degrees. Okay, so that was a nice practice question. All right. So what you got to do for this is to review all theorems and practice applying them in exam questions. Put your mind to it. You can do it. It gets easier every time you practice. Now, we're going to look into an example of an exam question. Now, we're almost done. We're just looking at two exam questions,